Hi, there's Mr. Rops.
And Mrs. Flynn.
Right, and this is our third method of solving simultaneous equations. So far we've done graphing using our calculator and substitution. Now we're on to elimination.
All right, so we're given two equations, both in standard form.
All right, and so now we have to solve for x and y. Now, one of the cool things about solving simultaneous equations is if I have two equations that are true. So if I go if I say something like 2 plus 3, I know that equals 5. And if I have something like, I don't know, negative 10 minus 2, I know that equals negative 12. If I add these equations together, if I go 2 minus 10, I get negative 8. 3 minus 2 is plus 1. And 5 minus 12 is negative 7. And so I get another equation that's true. And so this idea that if we add things that are true on the equal sign, if we add them together, we get a true equation. We're going to use that to solve that idea, to solve this simultaneous equations. So, in this case, when we look at our equations, we got 4x plus 3y equals 2 and x minus 3y equal to 8.
Right away, you should notice that we have a positive 3y and a negative 3y. That makes it easy to solve your equation.
So if I just add them up, I get a 5x
plus 0y.
Right, they cancel away. 0y
equals 6. No, 10.
10.
Adding.
I divide by 5 and I get x to be 2.
But we're not done because we've solved for the value of x, but we still have to find what y is.
Right, so if we go back now and put it into one of our equations.
Doesn't matter which one.
I get 2, put it into the second equation, minus 3y equals 8. Subtract the 2, and I get 6.
Now y is just negative 2.
Negative 2. And so it says xy equals 2, negative 2.
All right, that's our solution.
Right, if we want to check it, we could put it back in this top equation.
Okay.
So I get 4 times 2
plus 3 times negative 2. Does that equal 2?
Which is 8 minus 6, which indeed equals 2. All right, great. Let us try the next one.
Okay, this one's not so simple because if we notice, we have a 3x and a 2x and a 2y and a negative 5y.
Oh, well, I like to add as opposed to subtract.
So I see a positive y here and a negative y here.
So if I could take that first equation and multiplied it by 5, I would have a 10y.
So let's see, that would give me 15x plus 10y equals 35.
Okay. And if I take the second equation and multiply it by positive 2,
then I have 4x minus 10y equals 22.
All right. Oh, and that's nice. Now my y's, I have a positive 10y and a negative 10y, so they should cancel.
Those are gone.
Was that the only option that I could have done, multiply by 5 and by 2?
I think I could have multiplied, well, by any multiples of 5 and 2, right?
Right.
Or
if I wanted to eliminate the x's, though,
I'd have to multiply one of them by a negative. So I'd maybe multiply this by negative 2 and this a positive 3.
Right, which would mean negative 6x and a positive 6x. And then I could subtract away and eliminate the x's. Okay, anyhow, back to our scenario. Adding them up, we get 19x equal to
57.
Oh, good. X then is 3, I hope.
Yep, I agree.
Okay, and then plug it into either one of my equations.
So I'm going to pick the top one. 3x plus 2y equals 7. So 3 times 3 plus 2y equals 7. 9 plus 2y equals 7. 2y equals negative 2. And y is a negative 1.
Nice. Okay, so we get our xy point to be 3, negative 1. So if I graph those two lines, they should cross at that point. That should be the
Yeah,
point of
that's the
intersection.
point of intersection.
Nice. Great.
All right, I think we're done.
I think we're done.